Disorders of thinking and reasoning. Kind of an interesting chapter. Not very long. We won't be here very long, I don't think. I hope not, anyway. So let's go ahead and get started. Why I use the ballet dancers, I'm not exactly sure. It talked about disorders and it looked like they were hugging each other, so I thought that might be appropriate. These are the areas of the brain that we're going to be talking about. Probably not Broca's area very much, but the prefrontal cortex is the blue area. The motor cortex is in the parietal lobe. That's the green area, and then the premotor cortex is this yellow area. The frontal lobes constitute approximately 1/3 of the mass of each cerebral hemisphere, encompassing all tissue anterior to the central sulcus. Patients with damage to the frontal lobes area show a great diversity of impairments that may affect motor, emotional, social, or cognitive processes. The lobes comprise a variety of areas which are functionally and anatomically distinct and which can be grouped into three broad regions. You may wonder why I'm laughing. This is the second time I've started this. I made exactly the same mistake on comprise and anatomically. So evidently I can't read very well. The first region is the motor cortex, and we saw that as the yellow region back here. I'm sorry, the green region is the motor cortex. Um, the second region is the premotor cortex, just in front of the motor cortex, which was the yellow region that we saw, and then the blue region is the prefrontal cortex. The motor and premotor areas play an important role in the control of limb, hand, foot, and digit movements, as well as influencing the control of face and eye movements. Another region is the prefrontal cortex, which in humans can be subdivided into the dorsolateral prefrontal cortex, areas 9 and 46. And that one's this fuchsia one. That's not fuchsia, that's chartreuse. That's what color that is. The ventral or inferior prefrontal cortex, and that's this green one right here. It's got a different number on this one. And the medial prefrontal cortex, which isn't on this slide. Studies conducted in the early decades of the 20th century revealed rich and complex afferent and efferent connections to a variety of other areas of the brain. The prefrontal cortex receives afferent pathways from the auditory, visual, gustatory, olfactory, and somatosensory areas. Gustatory has to do with taste, of course. There are connections to and from many subcortical areas, including the limbic system, which plays an important role in arousal, motivation, and affect. The caudate nucleus, the part of the basal ganglia involved in the integration, programming, inception, and termination of motor activity. And the amygdala, which is implicated in the control of fear, rage, and aggression. Prior to injury, this is the strange case of Phineas Gage. Prior to injury, Gage was a conscientious and industrious railroad engineer whose responsibilities included placing and detonating explosives. On the fateful day in 1848, Gage was preparing the explosive using a fuse and a tamping iron, an iron bar 3.5 feet long and 13.25 pounds in weight. Gage placed the tamping iron on the explosive, prematurely detonating it, and the result was that the tamping iron penetrated his skull. And this is where it penetrated his skull, right under his left eye, and went all the way through his brain. It entered through the side of his face, passed through the left frontal lobe, and exited from the right frontal lobe. Gage survived, and the injury did not appear to have any major long-term effects, with the exception of a change in his personality. Following the accident, he was no longer reliable or considerate and showed poor judgment and poor social skills. These changes in behavior were a result of the frontal lobe's responsibility for planning and the maintenance of socially acceptable behavior. And this is how it went through, as you can see. And that's what it looked like. We still have his skull, and we still have the tamping iron that went through his skull. and it is in the Smithsonian, I believe. Esslinger and Damasio in 1985 described the case of an accountant who underwent an operation to remove part of his frontal lobes. Afterwards, he was very poor at organizing his life, even though he performed extremely well on a wide range of neuropsychological tests and achieved an IQ of over 130, which made him a genius. He was unable to hold down a job, went bankrupt, and was twice divorced. He was frequently unable to make decisions over relatively simple matters such as which restaurants to dine in or which clothes to wear. Frontal lobe damage has been found to impact several different aspects of behavior which are not necessarily mutually exclusive. One, drive. Typically, a patient fails to complete tasks on time. Despite knowing that the task needs to be undertaken, they will not quite get around to to doing it. Impaired social skills. Patients are frequently described as behaving inappropriately in social settings. In the more extreme cases, they may make inappropriate sexual advances and show aggressive behavior. In less extreme cases, a patient may make inappropriate and hurting comments. Lack of insight, patients do not monitor their own behavior or the reactions of others. This may hamper rehabilitation as they may not accept that they are performing poorly on tasks or in their social relationships. Della Sala et al. In 1998 comment that although not all patients show personality changes, certain recurring themes were observed, sometimes referred to as frontal lobishness or frontal lobe syndrome. One patient may show a higher level of apathy, another may display a contrasting picture of practical joking and disinhibited social behavior, and a third may display at different times both of these patterns. Benton in 1991 noted that the term frontal lobe syndrome was adopted to refer to this aggregation of deficits, perhaps as much as a convenient label as from any conviction that it represented a true syndrome. For example, a conjunction of inherently related symptoms. To avoid making assumptions about the area of the brain responsible, the term dysexecutive syndrome is often used instead. Alternatively, some use the term executive dysfunction to avoid the implications associated with the word syndrome. The case histories of those who have sustained frontal damage are rather perplexing in that any cognitive effects are often not immediately apparent, and there is little or no obvious mental deterioration. A considerable body of evidence has appeared which suggests that rather than being implicated in specific cognitive operations, frontal lobes are concerned with the deployment and coordination of cognitive operations. The frontal lobes have come to be regarded as being responsible for the highest forms of human thought, for the executive or supervisory functions of cognition, which refer to a range of related abilities, including our ability to plan and regulate goal-directed behavior, to deploy attention, and to use information flexibly. In some extreme forms of frontal pathology affecting superior medial prefrontal regions, patients are unable to start any action and lay down in bed during the entire day. This suggests that some cognitive processes exist that initiate or energize the beginning of an action, and that these processes are impaired in those patients. Schlisse and Gillingham in 2012 studied 40 patients with lesions in different parts of the frontal lobe. They found that superior medial patients were slower than healthy controls, and other frontal patients in simple and choice reaction time tasks, as well as in task switching and go-no-go tasks. The slowing down was fairly large and was disproportionately larger with more complex tasks, such as those requiring switching actions. As the slowing down was observed in all tasks, impairment of energization seems more plausible than more specific cognitive deficits. The reduction in ability of patients with frontal lobe damage to sustain their attention is evidence of their distractibility and their inability to inhibit automatic or habitual responses. During testing, their attention frequently wanders, and they will often report irrelevant things. Frontal patients have been observed to grasp or use objects placed near them. Lermiti in 1986 describes one incident when a patient was introduced to the bedroom where the bedspread had been removed from the bed and the top sheet turned back. The patient got undressed and climbed into bed. This behavior is termed utilization behavior and is dependent on external environmental cues which capture the attentional resources available to the patient. Patients are often conscious of this behavioral dependence but are unable to control it. Successful problem solving requires the individual to go beyond the information provided and engage in abstract thinking. A traditional way of assessing the ability to use and understand abstractions is to ask participants to explain proverbs. Thus, when explaining the meaning of Rome was not built in a day, the focus should not be on the exact location, Rome, or duration, one day, but on the time it took to build the Roman Empire. It has been known for a long time that frontal lobe patients often struggle with the task of explaining proverbs. Murphy et al. In 2013, studying 46 patients with frontal lesions, found that only the medial frontal patients performed worse than the control group. The left lateral group produced concrete errors 45% of the time, which was higher than right lateral patients, 12%, and healthy controls, 8%. Krawczyk's 2012 review of neuroimaging concluded that analogy tasks engage multiple parts of the brain. Areas in the occipital and parietal lobes, visual and spatial processing, were first involved. This was followed by engagement of several areas in the prefrontal cortex, the left rostrolateral prefrontal cortex, including BA10 and 47, presumably integrates information and performs explicit relational comparisons, while the dorsolateral prefrontal cortex and inferior frontal gyrus inhibit irrelevant semantic information and connect to more remote semantic association brain areas. Finally, the temporal lobes are engaged for retrieving semantic information. In Urbanski et al.'s 2016 study, where frontal lobe patients performed analogical reasoning tasks, damage to the left rostrolateral prefrontal cortex impaired analogical reasoning more than damage to other regions of the frontal lobe. Several studies have found that damage to the left prefrontal cortex impairs deductive reasoning, while this is not the case with damage to the right prefrontal cortex. For example, Goel et al. In 2007. A possible explanation is that these tasks are presented verbally and the left hemisphere is specialized for verbal information. Another explanation is that the left prefrontal cortex specializes in processing certain and complete information characteristic of deductive tasks, while the right prefrontal cortex is engaged with uncertain and incomplete information. Goel et al. In 2007 used problems involving either of these two types of information. They found a two-way interaction. Prefrontal patients with left lesions were impaired only with problems containing complete information, while those with right lesions were selectively impaired with problems containing incomplete information. The review of clinical cases has highlighted the difficulties that prefrontal patients face when making decisions. To study decision-making in patients with damage to the ventromedial prefrontal cortex, Becerra and colleagues in 1997 used the Iowa gambling task, in which participants have to select cards from decks that offer different rewards. While healthy individuals started making advantageous choices even before consciously realizing which strategy was the best, Prefrontal patients kept making disadvantageous choices even after they were aware of the optimal strategy. Weller et al. In 2007 compared the effects of lesions to the amygdala and to the ventromedial prefrontal cortex. They used an adaptive decision-making task where it was possible to separately assess decisions that could lead to gains and decisions that could lead to losses. They found that patients with damage to the amygdala made suboptimal decisions with problems involving potential gains, but not with the problems involving potential losses. By contrast, patients with lesions to the ventromedial prefrontal cortex displayed impaired decision-making with both types of stimuli. Consistent with these results, Studer et al. In 2015 found that damage to the ventromedial prefrontal cortex impairs the way risk is processed and thus affects decision-making under risk. This line of research has practical implications. Pathological gambling concerns gamblers who cannot control their gambling, with significant negative consequences to their finances and well-being, as well as to the well-being of friends and family. Prevalence is high in many Western countries, such as the UK and Canada, with important societal implications. Research has shown that problem gamblers display inferior performance in the Iowa gambling task compared to controls, which seems to be linked to a reduction in activity of the ventromedial prefrontal cortex. So what are we talking about here? It is possible that there is prefrontal cortex damage to people that are pathological gamblers. In other words, so where did it come from? Well, potentially it came from a blow to the head, which caused excessive trauma to the individual. How about that? There may be little correspondence between the cognitive resources tapped by some of the cognitive tests used in cognitive research and those tapped in real-world situations. This is one of the things, as I was reading this chapter, this is exactly what I was thinking. I was thinking, you're giving this person a card game to play, and you're making determinations from this stupid card game. The reality is, this is not real world. If I had a problem situation, this doesn't really fit a real world situation. If I was in a combat situation, I would be able to function. It's not like I'd be wandering around running into trees. So the real life, this was not real life. These stupid card games that they came up as Stroop tests, and this is my own personal prejudice. I was talking to my wife about it earlier. Anyway, this is what I determined. So, you can read the chapter and go, wait a minute, is that really right? Does that really measure what you say it measures? And there's lots of different answers. And I kept coming up with the answer, no, this doesn't measure what they're saying that it measures. But, I'm not a cognitive psychologist, so I don't believe this. You got to show me how this actually works on this certain portion of the brain. Real life problem solving is usually open-ended in nature, and different courses of action have to be considered and evaluated. It is rare that all the relevant pieces of information are available together, and frequently solutions to real life problems require a juggling of priorities which differ in importance according to the specific context. Therefore, there is a need to assess performance using tests that involve formalized versions of real-world activities and hence are more ecologically valid. Some patients with frontal lobe damage can perform well in many laboratory tests that supposedly tap frontal lobe function and yet fail in everyday activities. The situations where these patients have problems are those that A, offer concurrent task requirements, B, can be approached in a number of different ways, C, require decisions about how to allocate resources, and D, tap subtle planning, and perspective memory. In addition, while laboratory tasks consist of stereotype repetition of trials, provide repetitions of instructions, and offer numerous verbal prompts, this is not the case in everyday activities. And of course, that is the problem. This does not fit real life. This is a laboratory test that potentially has nothing at all to do with real life, with the real world. Characteristics of executive syndrome, abstract thinking problems, impulsivity, confabulation. Confabulation is where you believe anything that you're told. So it's you repeat everything that you're told as if it were the gospel truth. Planning problems, euphoria, temporal sequencing deficits, lack of insight and social awareness, apathy and lack of drive, disinhibition, variable motivation, shallowing of effective responses, aggression, lack of concern, perseveration, in other words, repeating the same thing over and over again, restlessness, hyperkinesis, inability to inhibit responses, knowing, doing dissociation, distractibility, poor decision-making ability, and no concern for social rules. These are the problems with people with prefrontal damage. I found this picture. This has to do with cooking. Wait a second, let me get to it. This is really kind of a funny video. It's a GIF. Norman and Schlisse in 1986 adopted an information processing approach to explain these deficits of executive function. Complex but well-established patterns of behavior are controlled by hierarchically organized schemas or memory representations. High-level schemas can call up subordinate programs or subroutines. Thus, for example, making dinner will have component schemas containing at the lowest level instructions on how to use the oven, and at higher levels how to make a cheesecake. And this had to do with cooking, and that's why I found this. I thought it was funny. She's turning the oven on with her foot. And the reason is because she's got a hamburger patty in her hand, and both of her hands are a mess. So that's why she's using her foot to turn something on. I'm guessing she was cooking barefoot. Fundamental to their approach is the distinction between habitual and novel action routines. They suggested that each of these are selected and integrated in different ways. Hello? Hello? Great. Norman and Schlisse suggested, hello? Hi. No. On what? PBS? Okay. Is it on at 8 o'clock? Okay. All right. All right. Okay. Yeah. Okay. Bye. Sorry. Norman and Schlisse, says my wife. Norman and Schlisse suggested that we frequently function on autopilot, selecting and integrating cognitive or behavioral skills on the basis of established schemas. Environmental cues trigger certain responses, which in turn trigger specific schemas. When there is a clash between two routine activities, an operation they call contention scheduling prevents two competing activated schemas from being selected through lateral inhibition. It is not always desirable to select schemas on the basis of the strength of their initial activation. Norman and Schlisse argue that coping with novelty involves a selection of schemas that are modulated by the operation of supervisory attentional system. This system can heighten a schema's level of activation, allowing it to be in a better position to compete with other schemas for dominance and thus increasing its probability of being selected in contention scheduling. Norman and Schlisse indicated 5 types of situations that would involve the operation of this system. 1, situations that involve planning or decision making. 2, situations that involve error correction or troubleshooting. 3, situations that require less well-learned responses or require the involvement of a new pattern of actions. 4, situations that are considered to be dangerous or technically difficult. 5, situations that require us not to suppress a strong habitual response to our resist or to resist temptation. Evidence for fractionation emerged when Stuss and Alexander in 2007 analyzed the effects of focal lesions of the frontal lobes. I'll be right back. I have to turn on the television. All right. I think it's already on PBS. They argue that the evidence points to at least 3 separate supervisory processes, each related to a different region within the frontal lobes. Energization. Energization, a function involved in initiating and sustaining a response. This is associated with the superior medial region of the frontal lobes. Task setting, a function involved in setting up stimulus-response relationships, such as in the early stages of learning to drive a car. This is associated with the left lateral region of the frontal lobes. Monitoring, a function involved in checking a task over time and adjusting behavior as appropriate. This is associated with the right lateral regions of the frontal lobes. And that is the end. I apologize for what's going on. My wife kind of messed me up. Okay, anyway, I'll talk to you guys next week. Let me turn this thing off. I don't know if I'm going to be able to find enough questions for a quiz this week, but we'll see what we can do.